Okay, we are in my IntelliJ project for the EX12 example. Keep in mind that these examples are all in my GitHub repository, in my live lessons Java 8 folder. And when I will post individual videos of these to my YouTube channel, and I'll put links to the locations of the source code in case you're curious to follow along. But they're all in various places in that Java 8 folder, even though not everything is Java 8. I should have called it Modern Java, would have been a better name. So this particular example is going to show off a whole bunch of modern Java streams terminal operations, such as different variants of forEach, collect, and so on, as well as several variants of reduce. And it'll also show kind of a classic Java example as a baseline, kind of what you used to do before we had functional programming in Java. And it'll also showcase and try to underscore how Java streams should be used with so-called pure functions, basically functions whose return values are only determined by their input without having any side effects. So we'll take a look at that and see how it works. So here's the test program. You can see we make a new instance of EX12, and then we run a bunch of methods to demonstrate different terminal operations. This is a good example of a pure function or a pure method where we pass in a string, and you can see that the result that comes back, which is a string that is properly capitalized, only depends on the parameter you pass in. So if you have a length 0, or if it was null, then we return S. So that doesn't make any changes, of course, because there's nothing to change. Otherwise, we uppercase the first character of the string, and then we go ahead and take the rest of the string and we lowercase that. So that is also demonstrating how strings in Java are immutable. So you can't modify them once they're created. You can only make new strings and then concatenate them together, as we're doing here, new substrings or other things. So let's take a look at a very simple example that uses classic Java features, which we'll use to provide a baseline to compare and contrast with the modern Java features. So here we're going to make ourselves a new linked list that will contain some characters from the play Hamlet. I'm a big Shakespeare fan, of course, so we have a bunch of character names. And then we write a loop. This is a loop that's an index-based for loop. And for every character in the list of characters, using the word character in slightly different ways, if the character at the location 0 is not an uppercase or lowercase h, we're going to just remove that entirely. Otherwise, we're just going to remove that character from consideration. And then we go ahead and capitalize the first letter of a Hamlet character whose name starts with H or H. So we go ahead and capitalize that and increment I by 1. When we're all done, we have an updated list of characters. And then we go ahead and use the collections sort algorithm to sort these in ascending order. And then we go ahead and use a for each loop to print the character names. So I think you'll agree with me that you've all probably written code that looks something like this. This is kind of the old school way of doing things. And for reasons that are described at length in the videos, this is a bad way to do stuff because it forces you into the Proustian bed of the sequential accumulator anti-pattern, which is evil for all kinds of reasons that are described in the slides and the videos. So let's see if we can do this some other ways that are more modern and more functional. So this approach uses the forEach terminal operations defined in Java streams. In this case, we're going to start out by using the stream of factor method to make a stream of characters from William Shakespeare's Hamlet. We then use the filter intermediate operation to only allow characters that are going to start with an uppercase or a lowercase h. We then use the map transforming operation to capitalize the first letter in each string. We then use the sorted intermediate operation to sort the results in ascending order. That's a stateful operation, as you may recall. And then the final thing we do is we use the forEach terminal operation, which will trigger all the intermediate operations above and print the results out. And I should probably say intermediate operation processing. And it'll print the results out by passing in a method reference to the println method that's part of the out object in the system class. Okay, so pretty simple, a little bit cleaner. Note there's no control constructs, there's no if statements, there's no loop statements, which is what the bane of this earlier example was. So you can read the thing from top to bottom. Okay, not too bad, kind of cool. Let's now take a look at a more interesting example. In this example, we're going to have a bunch of different lists of strings. So we're going to split stuff up. We're going to have 3 characters from Hamlet and then another 3 characters from Hamlet. And so basically Hamlet, Claudius, and Gertrude, they're all part of a family, of course, and Ophelia, Laertes, and Polonius are also part of a family. And then we've got a bunch of other characters that are sort of minor characters. And then we finally have the evil prince who's coming in to usurp the crown of Denmark. And that's Fortinbras. What we're going to do here is we're going to take all 4 of those lists and use the of factor method to make a stream of lists of strings. And then we're going to go ahead and apply the flat map operation in order to flatten out those lists. So we'll now end up with a stream of strings. You can see here, we had a stream of lists of strings, and now we have a stream of strings. And then we're going to limit ourselves to the first 4 elements in the stream. And what that will be is Hamlet, Claudius, Gertrude, and Ophelia, just those 4 characters. And by flattening the lists, then we were able to work on them as individual atomic elements as opposed to working on them as a stream of lists. You'll also see that we use the forEach ordered method here. For this particular case, it doesn't really matter because this is already going to print things out in encounter order. But had we run this as a parallel stream, it would have mattered. So forEach order just makes sure that things appear in the encounter order. Now let's do this again, just for kicks. And this time we're going to make a bunch of lists. We make 4 lists again. Just for kicks, we also use collections singleton list here just for some other diverse reason. And down here, we're going to show something a little different. We're going to use of, which we did before. So we have a stream of lists of strings. Then we're going to run this thing in parallel. So you can use the parallel modifier to convert a sequential stream to a parallel stream, wherever you feel like it, as we do here. And then we use flat map, and we flatten that stream of lists of strings into a stream of strings. We then remove any string that doesn't start with H. We capitalize them consistently, and then we print them in we sort them, and then we go ahead and print them out in the order that they have been sorted. And that just makes sure that they show up in the right order. So that will be another example illustrating a few more features, including forEach ordered. Let's now move to some other stuff and demonstrate other terminal operations besides forEach and forEach ordered. So once again, we have our list of characters from Hamlet. Notice that we're going to have Hamlet appear twice because, of course, there's 2 Hamlets in Hamlet. There's Hamlet the father, the original king of Denmark, and then there's Hamlet the son. And that always confused the heck out of me when I was in junior high school reading the play. Just like there are 2 Fortinbrasses, to a king and a prince of Norway. Very confusing. This time we're going to go ahead and stream the characters, get rid of anybody who starts with H, capitalize everybody's name, sort them, and then we're going to collect the results into a list. So we end up here with a list of strings as the result from this particular stream. And because we use a list, the 2 Hamlets will both show up because lists allow duplicates. Keep that in the back of your mind as we move to the next example. So then we go ahead and print that list as the result. Here's the same basic idea, except this time we're going to have the stream collect into a set, not a list. So everything else is the same. We've got 2 Hamlets. We've got a stream of these characters from Hamlet. We get rid of anybody who's not starting with capital or lowercase h. We capitalize stuff. And then we go ahead and notice in this particular case, we don't bother sorting because in this particular case, the list is going to be sorted. And a list by default uses a uses a tree set. And so in this particular case, we say toSet, we get back a set, which will be ordered. And also, as you can see in this particular case, we're going to end up with no duplicates. So one of the Hamlets is going to get left out. So there's only 1 Hamlet, not 2. Just for kicks, we do this yet again, except this time we're going to collect into a map. So everything looks kind of the same as before, except this time collect is going to use the toMap factory method, which will go ahead and make the key of the map be the current element in the stream, which would be, again, characters starting with the letter H in the characters from Hamlet. And then we're going to make the value part of the map be the length of the name. So it'll be the length of the name is the value. And anytime you have two or more keys that have the same value, kind of use of the word value in a punning way, any two keys that have the same name, then we're going to add up those and sum their lengths and make that the new length. So Hamlet, of course, here would end up being 12 as opposed to 6 because it appeared twice in that particular string. Just for kicks, here's yet another variant of using a stream. This time we're going to use the same characters, but we're going to use the grouping by factory method to create the appropriate collector. And grouping by, as you can see, has some additional stuff. So it takes identity, just like we did before, but you can also tell it what kind of map to use. So we're going to make a tree map just for kicks. And again, that'll end up making things be sorted. We don't have to sort them because the tree map will sort them by key. And then we make this last parameter, which is called the downstream collector, be what will create the appropriate value for each key. And in this case, it's going to sum up the quantity of the lengths of the string, of the name. So it'll basically have the same effect as what we did up here with this map, except unlike this one, we can control the kind of map that's made. ToMap makes a hash map, whereas down here, we can control what kind of map is made. We can make a tree map if we want a tree map. Now we're going to show a bunch of different examples that use reduce, which, as you recall, is another terminal operation that's very common, very powerful. And the main difference between collect and reduce, which is probably important to know for the quiz, is the fact that collect works on what's called a mutable result container, whereas reduce will work on so-called immutable objects, or they're expected to be immutable. If they're not immutable, then weird things will happen and your life will be miserable. What we do here is we take a string containing the characters from Hamlet, and then we compile that into a regular expression pattern using comma as the symbol to break the string up into a stream. So we split the string into a stream based on the comma, which ends up with a stream of Hamlet characters. We filter out anybody that doesn't start with a lowercase or uppercase h. We capitalize everybody, and then we go ahead and group them together. And then we go one step further. We're going to take the matching characters map, which is what we created up here. The matching characters map is what we end up collecting this stream into. And then we're going to extract the set of values in this map. I guess it's actually a list. We get the list of values in the map. No, I take it back. It's a set because there are no duplicates. We take the values from the map, which are all the lengths of the character names. We turn that into a stream of lengths of character names. And then we use the reduce terminal operation to sum all the lengths of the character names together. And we pass in the so-called identity value, which is 0 for addition. And then we sum up the results using long : : sum, which, as you can see, is a nice method reference. And we could have written it out more long-windedly like this, but we chose to do it concisely using a method reference, which is one more reason I love method references relative to lambda expressions, because they're a little verbose. Down here, we have another example of using reduce, same input. We split a string using a regular expression pattern into a stream, and then we collect everything together with the tree map. And then down here, we're going to do something ever so slightly different. Rather than using reduce, instead, we're going to convert each element in the stream of longs into a stream of long primitives. So we went from long objects with capital L long, to lowercase l long primitives. And then we use the sum method to sum everything together. And that's a good thing to remember, that sum exists. And you'll see that when you do the next programming assignment. So we get the same results, print those things out. Here's yet another way to do this. So again, same input processing, except down here, what we do is we replace the use of reduce with collect using the so-called summing long collector. So it's a factor method that makes a collector that will sum things together and will convert the capital L long objects into lowercase l long values this way. And you can see that IntelliJ really wants to replace collect with this. It would rather do it like that. it for some reason thinks that's a better way to go. It may be a better way to go, but I wanted to show how you could use collect together with summing long just for kicks. And then I think this might be the last example. Once again, we make ourselves a list of characters in Hamlet, not a map, but a list. So we have a list of characters. And then what we're going to do is we're going to go through here, create a parallel stream, and then use the 3-parameter version of reduce, which is sometimes called the map reduce. And what it does is it has an accumulator method that will be worked on for certain of the elements that are being processed. And you can see what it does there is it keeps a running sum of the lengths, and it adds the new length of every string to that running sum. And then the reduce part, which is the 3rd parameter, takes all those running sums and sums them together with long : : sum, which is the method reference. So again, just illustrating a whole bunch of different ways you can use terminal operations in Java streams, both for sequential streams as well as parallel streams. My favorite would most likely be collect. That's kind of the workhorse, but there are situations where you can also use reduce or some variant of reduce like sum or collect with summing long or whatnot in order to be able to get primitive values as a result.